Hey, this is Phil with PnP Tech. Wanted to do a quick demonstration of our high flow bypass valve. This bypass valve is meant to go with our chiller kits for those who want to run a heat exchanger in line with the chiller. The bypass valve will sense the temperature of the coolant and then bypass the heat exchanger as it dips below a certain preset temperature. In this case, this valve set to 100 degrees Fahrenheit. But here's the actual valve itself. What we have set up is I've got a simple utility pump to provide flow, and then I have just a bypass valve, a ball valve in between the pressure and suction sign to kind of help me control the flow. Since this pump is a 1/2 horsepower, it's quite considerably larger than what you would find in a automotive application. But then I've also got just a quick clamp on the suction line to help me dial in the flows of the setup, because I'm getting data on all the flows of the different flow rates of the system and how the valve responds. So I'm pulling in water from a reservoir coming into the pump, and then from the pump it reaches this first setup here. This is a flow meter here, a turbine style flow meter. I've got a pressure gauge. This is telling me the system pressure, and then a temperature transducer which feeds up into this first system here, which provides the flow rate in GPM, and then the coolant or the current temperature of the coolant going through. So flow from the pump into the high flow bypass valve. Now as the temperature decreases, this valve starts to open inside, allowing coolant to bypass through here instead of going on into your heat exchanger. As the temperature rises, this thermostatic valve starts to close this internal poppet, forcing the coolant through the heat exchanger and then back through the valve. There's another flow set up here. This is giving me flow of just what's flowing through the heat exchanger. I'm also getting pressure, and I'm also getting temperature. So the pressure reading here is the pressure across the valve, and then also if there is flow into the heat exchanger, I'm getting a pressure drop shown here across the heat exchanger. So that's reported right here. As you can see, the coolant temperature right now flowing through it. I'm flowing just under 10 GPM at 100 degrees F. I'm getting no flow whatsoever on the heat exchanger side, but I am getting a tiny little bit of pressure. So you can see here we're running about a PSI of pressure, and here it's about a little less than a 1/2 PSI of pressure. So at 10 GPM or 10 GPM, we're getting less than a PSI of drop across this thermostatic valve. Taking a ton of data on all the temperatures. So right now about 100 degrees of coolant temp, it starts to shut off the factory heat exchanger, and it'll work just on the chiller from here on out. As the temperature starts to rise from 100 degrees up until about 115 degrees, it'll lock off all cross flow in this valve, and it'll push all flow through the heat exchanger. So neat little system. No wires in and out of this valve whatsoever. It's all self-contained, no power, no relay. There's just a thermostatic cartridge in here, a low temp thermostatic cartridge that works and moves this thing in and out. Very simple, very fail-safe. It's got -12 O-ring Boss ports, so you have the 4 ports here. It's hard to see, but a quick diagram of how to plumb the valve up itself. Yeah, let's kick the flow up a little bit here. You hear the pump tone change. So now we're up to 16 GPM, which this is probably way above what any 12 volt pump will run at on a system. But you can see we're at 3 PSI here. And we're getting just a tickle of flow at 99 degrees F. As the water temp comes down, this valve will open up even more, and that flow should go to virtually zero. So, but I mean, literally just a slight tickle of flow at that high of a flow rate. So, works great. I'm going to continue taking more data just so we have it to present to our customers. But another thing too is this would work great with ice tanks, and then the big problem with ice tanks is you put 50 pounds of ice in it and you pump it through your heat exchanger. Well, if you're pumping 30-degree water through your heat exchanger, it's actually a heater, not taking, it's putting air into the, or heat into the water, not putting heat into the air. So it's working in reverse and melting your ice faster. So these valves will work great for ice tanks as well. Doesn't have to be with the chiller. So pretty cool stuff. Thanks for watching.